Swayam Prabha. Digital India. Educated India.
Let us assume a special state of stress called as plane stress. For simplicity, I do not want to multiply all 3 by 3 stress sensor to see what happens. So, I am restricting myself to plane stress, which means the definition of plane stress is determinant of the stress matrix would be 0 for a plane stress. In other words, sigma can be written as sigma xx, sigma xy, 0, sigma xy, sigma yy, 0, 0, 0, 0. I have one row and one column of zeros. I have one column and one row of zeros, indicating me that the determinant of the sigma will be 0, and this represents a plane stress state. Okay. Now, I have used here sigma xy equal to sigma yx, y we will see later. For simplification, I have assumed this, and this holds true. Okay. We will see the reason for this later, why sigma xy is sigma yx. Okay. Now, I have got q, I have got sigma. Now, let us go and substitute and find sigma star. I want to find sigma star. So, I have to do a q transpose. Q transpose would be cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1 multiplied by sigma xx, sigma xy 0, sigma xy, sigma yy 0, 0, 0, 0 into cos theta minus sin theta 0, sin theta cos theta 0, 0, 0, 1. This is q. So, let us first do these two multiplication. What will I get then? I will get sigma xx cos theta, again going back to the second lecture, sigma xy sin theta minus sigma xx sin theta plus sigma xy cos theta 0, sigma xy cos theta plus sigma yy sin theta minus sigma xy sin theta plus sigma yy cos theta 0, 0, 0, 0. Now, when I multiply this matrix with this q transpose matrix, I will get sigma x star, sigma x star, y star, 0, 0, 0, 0, this matrix to be sigma xx cos square theta plus sigma yy sin square theta plus 2 times sigma xy cos theta sin theta. Okay. That will be the first term. This, the second term would be this multiplied with this column. So, that will be sigma xy cos square theta minus sin square theta plus sigma xx minus sigma xx, okay. It will be plus sigma yy into sigma yy minus sigma xx into cos theta sin theta, okay, and the third component is going to be 0. Similarly, here this is going to be sigma xy into cos square theta minus sin square theta plus sigma yy minus sigma xx into cos theta sin theta, and the second term here is going to be sigma xx sin square theta plus sigma yy cos square theta minus 2 times sigma xy cos theta sin theta 0 0 0 0. Okay. Now, I am equating these two matrices, to see what is happening. I am equating these two matrices to find that sigma x star is going to be sigma xx cos square theta plus sigma yy sin square theta plus 2 times sigma xy cos theta sin theta. Okay. This using the trigonometric identities can be written as sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus sigma xy sin 2 theta, where I use the fact that cos square theta is 1 plus cos 2 theta by 2 and sin square theta is 1 minus cos 2 theta by 2 and sin theta cos theta is sin 2 theta by 2. Okay. Similarly, sigma x star y star would be sigma xy cos square theta minus sin square theta plus sigma yy minus sigma xx into cos theta sin theta, which will simplify to sigma xy cos 2 theta plus sigma yy minus sigma xx by 2 sin 2 theta. Okay. Finally, sigma y star would be sigma xx sin square theta plus sigma yy cos square theta minus 2 sigma xy cos theta sin theta will simplify to sigma xx plus sigma yy by 2 plus sigma yy minus sigma xx by 2 cos 2 theta minus sigma xy sin 2 theta. Okay. Now, before moving further, we want to observe a few things. We can observe that sigma x star plus sigma y star is equal to sigma xx plus sigma yy, that is trace of sigma. Okay. This is straightforward to see. Here the cos 2 theta terms have a negative sign, this is sigma xx minus sigma yy, here is sigma yy minus sigma xx. So, this will get cancelled. Similarly, sin 2 theta terms get cancelled and hence you have this observation. The second observation is sigma x star squared plus sigma y star squared plus 2 times sigma x star y star squared will be same as sigma xx square plus sigma yy square plus 2 times sigma xy square. This is nothing but trace of sigma square. Okay. Now, trace of sigma square is nothing but sigma square will be nothing but for the assumed matrix. You can compute this and see sigma xx square plus sigma xy square sigma x x into sigma xy plus sigma yy to sigma xy 0 sigma xy into sigma xx plus sigma yy sigma yy square plus sigma xy square 0 0 0 0. Okay. So, trace of this would be what I have given here. Okay. Now, to see this, what I do is I have to square and simplify. Okay. I will leave it as an exercise for you to show that. Okay. So, you can show that this holds, these two relationship hold, and of course, you know that determinant of sigma is same as determinant of sigma star. So, this is 0, both of them are. Okay. So, what this means is there are certain quantities like trace of sigma square that do not change with the coordinate system. Okay. The components sigma xx or sigma x star will change with the coordinate system, but these components trace of sigma square, determinant of sigma does not depend on a coordinate system, and these are called as the invariants of the stress tensor. Okay. Trace sigma square, determinant of sigma are called as invariants of stress. Okay, because these do not depend on the coordinate system that is used to represent the stress tensor. Okay. So, what we have seen is we have seen that for a plane stress, when I change the coordinate system, when I rotate the coordinate system by an angle theta in the anticlockwise direction, how does the components of the stresses change? These quantities sigma x star y star and y star. Okay. There are a couple of observations we have to make before we end this lecture. The observations are the following. First thing is, I look at this equation sigma x star minus sigma xx plus sigma yy by 2 the whole squared plus sigma x star y star squared. I want to compute this based on the equation that we had before. Based on these equations, I want to compute sigma x star minus sigma xx plus sigma yy by 2, square this term and add them. You can see that it is cos square plus sin square theta. So, that will be 1 if I square them, and the other term 2ab term will get cancelled because this is negative of the other, these two are negative of the other. Okay. So, what you will find is, I will leave the algebra for you to do, you will find that this is nothing but sigma xx minus sigma yy by 2 the whole square plus sigma xy squared. Now, what does this equation represent? This equation represents something like x minus x naught squared plus y square equal to r square. This is equation of a circle. Of radius r centered about x naught comma 0. Okay. So, we will draw this circle and interpret what the circle means in the next lecture, but before stopping for today, I want you to observe that sigma y star and sigma x star, if I rotate it by 90 degrees, if I rotate the coordinate system by 180 by 90 degrees. If I rotate the coordinate system by 90 degrees, you will find that sigma x star becomes sigma y star. Okay. That is, let us say I want replace theta with alpha plus pi by 2. Okay. Now what happens in sigma x star relation? I will get sigma x star as sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 into cosine of 2 times alpha plus pi by 2 plus sigma xy sine of 2 times alpha plus pi by 2. Okay. Now this is nothing but 2 alpha plus sigma xx minus sigma yy by 2, 2 alpha plus pi, 2 alpha plus pi is minus cosine of 2 alpha, and this is 2 alpha plus pi again, that will be minus sigma xy sine of 2 alpha. Okay. So if I replace this, what I get is sigma x star becomes sigma y star with alpha as the angle replaced in, with theta replaced by alpha in sigma y star expression. Okay. Now let us understand why this is happening in the next class. It will be clear when we draw the Mohr circle equation. Okay. When you plot this, this will become clear why this happens. Okay. Just observe that this is nothing but by 2 will be sigma y star. Okay. So we will conclude the lecture here for today. We will start from the Mohr circle equation in the next class. What we have seen in today's lecture is basically what are the meaning of the components of a stress tensor mean, how do you get the components of the stress tensor, and what happens when the coordinate system changes to the components of the stress tensor. Thank you.